I'm going to talk about my recovery from addiction, Part 1. I'm Sean Kelly. But first, some history. 1987, I learned the C programming language, mostly so that I could use this computer and this C compiler to write games which would someday hopefully look like this. In 1994, my game writing career never did take off, and I needed to pay the rent, so I learned the C++ programming language, and found that object-oriented programming gave me enormous benefits and boosts in productivity. C++'s features were also quite handy. Unfortunately, C++ was compatible with C, and that made it very messy indeed. Template instantiation also took a very long time, and so the compile, run, debug cycle came to a screeching halt. Despite that, my productivity was improved that over C. In 1997, I caught sight of Java and saw, wow, it's a lot cleaner than C++. Plus, it had a whole bunch of really handy features, with a huge API that made developing applications as simple as just putting together the right blocks. Again, my productivity improved, and I became quite addicted to Java. Unfortunately, I was also blinded to a lot of other technologies that were out there that made it easier to develop web applications, which by the 2000s were the only kinds of applications I was really developing. So in 2006, I finally took the time to evaluate a lot of those other technologies that were out there, or at least some of them, and made the now famous screencast Better Web App Development, which is still on the web at this address should you like to take a look. By 2006, the Java API as well had, was starting to collapse under its own weight. And using that API became more and more difficult. It seems that just about every class has a XML configuration file, and to actually get objects, you have to go through several layers of factory objects. My productivity with Java seemed so much more slower than those using more nimble and agile technologies, and by comparison, my productivity was plummeting. In addition, code is read a lot more than it's written, and so any kind of technology which would reduce wordiness and reduce lines of count would be a good thing. Unfortunately, Java is super verbose. In fact, I would go so far as to make this assertion. So I absolutely had to learn a new language. But what? PHP? Well, PHP single-handedly popularized one of the most ubiquitous attacks on the web, the SQL injection attack. Has object-oriented features that were sort of tacked on as an afterthought, whose very behavior changes depending on settings in a configuration file, making your scripts definitely non-portable. No, definitely not PHP. In fact, I would go so far as to make this assertion. So it's going to be one of these two. Which one? Well, Ruby borrowed a lot from Perl, and I really don't like all the cryptic symbols that Perl and therefore Ruby uses. Unicode in Ruby is a little bit broken right now, and the folks at Google really seem to like Python, so Python seems like the right answer. As a result of my using Python, my development is much faster than it used to be, and I'm a much happier programmer. What I want to do now is give you Java addicts out there a taste of what life is like here on the other side of addiction. What I'll do is give you one of what I hope will be many such screencasts that will show you Python's elegance and simplicity and concision. What we'll do is make a coordinate object, coordinates to track latitude and longitude right here on planet Earth. In Java, you would do this by making a public class coordinate with two private float fields to hold your latitude and longitude. Throw in a noargs constructor and then a constructor which initializes those two fields, plus your getters and your setters. That's 21 lines of code, and a lot of typing. Now I know you're going to say, well, hey, my integrated development environment takes care of that for me. It'll generate my getters and setters, but that's really not the point. Remember, code is read more than it's written, and anyone who goes then traipsing through that code has to put up with a lot more visual noise, and that reduces productivity and efficiency. The Python version looks like this. Make a class coordinate which derives from object, make an initializer with lat and lon which have default values, and assign those as fields of each object. That's just 3 lines of code. It's clear, concise, and elegant. Now you're going to say, well, hey, the fields are public in Python. Anyone can touch any part, right? Yeah, in fact you can. You could do something sort of illegal like this, put in a bad value for a latitude. But the philosophy in Python is that we are all consenting adults. That is, we're all mature enough that we will not break encapsulation or do illegal or stupid things, and that the language is not going to go out of its way to prevent this because we have a level of maturity which tells us that that's a bad thing. So breaking encapsulation is something that is allowed in Python. And when's the last time you ever willingly broke an encapsulation in Java? Or even needed to? Yeah, you can do it, but why bother? So the philosophy of Python, that we're all consenting adults, helps make Python a little bit more agile and nimble than Java. Could we apply that same philosophy to Java? Let's try it. Let's see if we just make the lat and lon fields public in Java, then suddenly maybe we could make Java a agile language. We still need our noargs constructor and our constructor which initializes the fields. But hey, now we're just down to 9 lines of code. Maybe there is hope for Java after all. We can even do the illegal thing. Eventually, your coordinate class will make it into production, and production code, say a telemetry tracker, which receives data from the satellite and wants to update its last location, might look something like this. On the left, we have the Python version, and on the right, we have the Java version. Yes, we are touching public parts here, but remember, we're consenting adults. And of course, the longer code is in production, eventually something might happen that looks like this. That is, some bad data comes from the satellite. It's all garbled. And what does that do to the decode lat function? Does it come up perhaps with an illegal latitude or a cryptic series of numbers? This is clearly a bug, and it's something that we've got to fix. For instance, though, let's just say that you are the maintainer of the coordinate class and the telemetry tracker is in someone else's bailiwick. So you decide to put in a check inside the coordinate class to check for an illegal latitude. In Python, what you would do is add a getter and a setter. The getter will just return a field called underscore underscore lat, and the setter will then check to see if the incoming latitude is an illegal one, and if so, raise an exception. Otherwise, it will just assign it. Then we use this special property function. We say lat is a property whose getter is getLat and whose setter is setLat. We can test this out from the command line, and we get a little handy-dandy stack trace that tells us that it works. And then when we present bad data to the telemetry tracker, we get a nice handy-dandy stack trace from the telemetry tracker all the way down into our types module, even pointing out that the setLat function received a bad latitude. But client code, best of all, was unmodified. Before, the telemetry tracker was accessing a lat field, and now it's accessing a lat property, but it doesn't care. It gets all the benefits of the check for illegal values without having to be recompiled or retouched. Can we do this in Java? Well, we'd first make the lat-lon fields private, we'd add getters and we add setters, but client code would need modification. Anywhere we attempted to assign that lat field, we'd have to change it to a call to the setLat function. This is bad. In the end, Python gives you a choice. You can choose to use properties, or you can just allow clients to touch the public fields directly. And you can even change your mind later. It gives you a far more expressive and concise way to manipulate your objects and their properties. With Java, you don't get the choice. Not to mention that the Python version being so much lighter weight is also a big win. That's it for part 1. Thanks for listening.